let's talk about the data quality actions. That is, we've talked about the actual flow of the data quality management activities. However, when we're talking about remediating data, it's not as simple as just fixing data. I mean, it can be in some cases, but there are other things that we can do, which are very valuable under specific circumstances. Usually, there are three main types of activities: remediating the actual data, finding the root cause of the problem, and creating a rule to prevent the problem from occurring again. Let's take a look at these in more detail. When faced with a data quality problem, as mentioned, we can remediate it. But going deeper, there's usually three distinct types of actions that we can take in this type of situation. The first is the actual correction and remediation of the data. The usual task, if you will. That is, you take wrong data and you increase their quality in some way. You add missing data, you parse and standardize the values, and so on. The second option is to perform root cause analysis. And this is because the data problem that we found may already be in a downstream stage of the data lifecycle. In other words, fixing the problem here is not going to magically fix it in the earlier stages, nor will it prevent the problem from actually occurring again, because we didn't handle the source. So that's exactly what we do here. And the third type of action is instituting some kind of prevention and monitoring mechanism. That is, even if the problem is addressed, and even if it's addressed at the root cause stage, it doesn't really mean that it can't happen again. So monitoring allows you to automatically monitor the quality of your data and to raise alerts if a problem occurs, preventing it. You can just perform monitoring, or you can also perform prevention, addressing the problem early on. Both can be done. Let's start with data correction and remediation. As mentioned previously, they simply address a specific data quality problem. That is, maybe the data are missing, maybe they're not within range, maybe they're not consistent across data sources, and so on. This is usually done by parsing the data and then cleansing it or standardizing it. And we'll dive into this later. But when remediation is performed, it's also important to understand the consequences, both upstream and downstream. First, it's important to ask yourself if there are data at an earlier stage that contain the same error and that need fixing, just like the dataset that you're addressing. That's the goal of root cause analysis. For example, you fix the data in a report, but you leave the original data untouched. You can probably guess what happens next, right? This is going to create more errors because any future report still depends on flawed data. Then we have the opposite consequence, which is, are there data at later stages which are affected by this correction? For example, many transformations may depend on the data as is, and changing the format of these data will crash that process, even if we fixed it for a good reason. For example, you have a database field with prices that for some reason are in a character field and not a floating number one. And there's a transformation process that takes this into account and performs a parsing of the floating numbers. So far, so good. We found a way to actually work with bad data. But let's say that you fix the data in the original source by creating a floating number field and removing the character field, or replacing one by the other. The data are in better quality, technically, but the transformation process may not know this and it's going to crash because it's expecting data in a specific format. That's why it's important to, if possible, perform impact analysis on any data remediation attempt. Because sometimes people develop for bad data and they get used to bad data, and actually fixing them breaks those processes. Then, a concern that usually emerges is determining the source of an error. As mentioned, data quality errors can occur at any stage of the information lifecycle. Data can be created with errors. For example, someone enters data with typos. Data can be transformed with errors. For example, an extract transform load process that misses a field when taking data from the operational database and stores it in the data warehouse, or that ignores the decimal part of a number. Or data can also be manually edited with errors. That is, they can be changed and the wrong information may be inserted. So, as mentioned, if it is possible, performing root cause analysis becomes an important process. And root cause analysis is nothing more than determining the earliest stage possible at which an error is present. In one document that becomes crucial here is some kind of data map or data flow or information flow. Companies that manage data in a sophisticated manner will probably have some form of this. And some regulations, such as the PCI DSS, even demand it. But this document is important because it shows you the full pipeline, all stages. Where are data created? Where do they move to? How are they transformed at each stage? And where do they end up? This is very important to identify the different stages, especially when fixing data. So assuming that you are armed with a quality data flow document, then root cause analysis becomes very simple. Not necessarily easy, but simple. And the source of the data problems can be identified by a simple comparison process. For example, if you have 10 stages in your information flow, just profile the data at each stage, one by one. Engage where the data are good and where the data are bad. And when you find the first stage with an error, that's the source of the error. Done. For example, let's take a very simplified situation. Customer data in an organization only has 3 stages: creation, through direct form entry; transformation, through ETL to store in a data warehouse; and usage for customer reports in the data warehouse. Let's assume that these are the only steps. And in this case, we simply analyze data for errors at all 3 of these stages. For example, let's say that we're missing the customer address. So we first check the creation stage. At this stage, it appears the addresses are okay. Then we check the transformation stage. Addresses are not okay here. Profiling reveals it. So the error was almost certainly introduced at this stage. And we can stop here, or we can continue to make sure that the error continues in other stages. For example, at the usage stage, maybe the error is still there. Or maybe someone actually fixed it, or maybe they created another error. But here's the thing, right? It's important to note that certain data flows may have dozens of steps, and they may be used by thousands of users concurrently. And on top of that, there may be data for very sensitive purposes, such as patient data in a database for surgery, and that database can't really be stopped for remediation or maybe even for profiling. So verifying data quality at every single step may not be viable in a company in all situations. Remediation is already pretty intrusive, so it may not be viable. But even actually checking the data, profiling the data, may also not be possible, because it may be a very big processing load in a big database, for example. And additionally, we can also introduce the question of whether to check the whole dataset or just a sample. And this becomes relevant with gigantic datasets that are computationally expensive to profile. If you have a list of 20 customer addresses, obviously you can profile the full database. But if you have a list of 2 million records, it may be useful to take a sample of 100 instead of analyzing the 2 million, especially if processing resources are limited, or if it's a database for real-time critical operations. So situations can be very different, and there is no right answer here, right? Each organization can afford different intensities of profiling and remediation, and they can check a number of relevant information stages as well as using a relevant number of sample sizes, which may be doable but still significant. For example, if we have 20 stages in the data flow, maybe let's not examine the 20, but maybe split the pipeline into 5 parts and analyze the 4 checkpoints between those parts. And maybe if the datasets are of 20,000 records, let's take a randomized sample of 100 or 1,000 at each one of these 4 checkpoints, and we start there. And finally, monitoring and prevention intersect with data governance and with metadata, as we mentioned. In short, you will come to the conclusion that data quality problems occur because the data don't obey the rules or the requirements that we have for them. And they usually don't obey these expectations because we don't have controls forcing them to obey them. For example, let's say that each customer must have an address. That's a data validity rule. All customer records with no address are officially a data quality issue that must be tracked, must be profiled, and must be remediated. And through many sources, such as actual data profiling, or data steward metadata entry, or even consumer feedback, you will determine these data validity rules. That is, you may already start with this actual rule, knowing that they need an address, or you may reach that conclusion through conversations, feedback, or the data steward investigating. But one way or another, you will come to these rules. And then monitoring is nothing more than the automated testing of data against these rules. It's almost like software testing, but instead of testing the software, you test the data. For example, testing every entered customer record for an address in real time. If you have a relational SQL database, this can usually be done through triggers. Every time a record is added, an alert is triggered if it doesn't fulfill certain conditions. Naturally, other types of technology may require custom scripts or commercial monitoring tools, but usually there's some sort of automated way to check these. And as mentioned at the beginning, the monitoring mechanisms can go beyond alerting you and actually prevent the entering of incomplete data, or at the very least, alert you when that occurs. And again, this is a decision that's up to the organization. Would you rather sacrifice a record and not enter it at all to preserve data quality, or would you rather let it go into the database but actually flag it as low quality data? It depends on what you're trying to achieve. If you have critical data, for example, maybe you want to accept it even with errors, but flag the errors right away so that it can be fixed afterwards. There is no right answer. What are some examples here? The first is access control and permissions. Since data managers and analysts will be profiling different types of data and for different issues, then permissions and access control become very important here. Although data managers mean well, they should not have unlimited access to all types of data, such as personally identifiable information, credit card information, or others, and there should be strict controls in terms of masking or hashing that information, as well as preventing any exfiltration of those data and placing limitations on the devices that someone can use to access the data. A very good practice is for a database administrator to determine what sensitive information must be encrypted or protected, and then you hand the data over for profiling to the data management team. Then, notice that big data bring a lot of complexity to this process. The sheer volume of data makes remediation a lot harder, if not impossible. You can't be defining rules for data entry and fixing data in real time in the data warehouse if you are loading hundreds of thousands of records per minute instead of 2 records per minute. That would be absolute chaos. In terms of big data, one interesting insight is that remediating the data after processing has become reasonable. In other words, instead of having an ETL process to clean and standardize the data and then load it, in many cases, companies are loading the raw data into the data warehouse and then processing them. And in many cases, this also makes companies lean towards data lakes instead of data warehouses because they don't need a specific schema at the time. But that's another story. And finally, there is an opportunity for integration with the broader information security controls here. Because look, the data governance prevention and monitoring tools and techniques can easily be integrated into a bigger suite of monitoring as part of the information security strategy of the whole company. Because look, in terms of information security, you probably already have controls for file integrity, for intrusion prevention, for configuration management of systems, for IP auditing, port scanning, or other automated tools. And this can be just another one integrated in that portfolio. What are our key takeaways here? The first is that there are usually 3 main types of actions that can be taken when faced with a data quality problem. Fixing or remediating the data is the first one, analyzing the root cause of the problem is another one, and preventing future issues is the third option. One or all of these can be executed. Remember, many stages can be impacted. Remediating data at one stage doesn't really mean that it's going to be fixed everywhere. This will happen if you fix data at the earliest stage where the issue occurs. But if you didn't, there may be earlier errors, and the fixing itself can also cause later errors due to changes in formats. This must be measured. Then, root cause analysis is performed by simply detecting a data quality error and then checking for its presence at different stages of the data lifecycle and finding the earliest one where the error is present. But naturally, this assumes that you do have that kind of data flow and that you can also profile information at different stages. Both of these may not be guaranteed in a given organization. And finally, monitoring and prevention are all about automation, defining automated tasks and rules that the data must obey. By automating that verification alerts can be raised. So as we see, we have three major operations which are all important. They're not always possible, but all of them have an advantage. You can remediate the data, you can find the root cause of the problem, and you can create rules to prevent the problem from occurring again. And remember that data problems can occur at any stage in the data flow, so it's important to have a data flow in the first place. Also remember that you may not be able to analyze all of the specific steps of the flow to find the root cause of a problem, and you may not be able to remediate the data on every stage. It all depends on the specific organization and how critical the data are.